The James Webb Space Telescope just dropped a discovery that has scientists tearing up the rulebook. It didn't just peek at ancient galaxies. It may have mapped the very first signs of the real edge of the observable universe. But what it found is unsettling. Instead of a smooth cosmic horizon, Webb saw structure, clusters, strange movements, and hints that the universe might not even be symmetrical. We always thought the edge was just a blurry time limit, a point where our view fades into nothing. But now the data whispers something wild. Something could be pulling at us from beyond. NASA has practically drawn the universe's border, and it looks nothing like decades of predictions. Even worse, the images pouring in from JWST are wrecking our understanding of how the cosmos evolved. Near the farthest edge, galaxies aren't faint and primitive. They're huge, glowing powerhouses, packed with metals and mass like they've lived through several generations of stars. All within just 300 million years of the Big Bang. And it gets crazier. Monster black holes show up almost instantly after the universe began. One in galaxy UHZ, one tips the scale at up to 100 million suns, when the cosmos was only about 470 million years old. Then came the jaw-dropper. The Cosmos Web Survey mapped nearly 800,000 galaxies in extreme detail and found 10 times more galaxies in the early universe than Hubble ever hinted at. As Caitlin Casey, the project's co-lead, admitted, the universe was producing too much light too early. With just 400 million years to create a billion suns worth of stars, scientists are straight up stumped on how it even happened. Some cosmologists now think the universe might have skipped a step, with giant clouds of primordial gas collapsing straight into black holes without ever forming stars first. This direct collapse idea could explain how such cosmic monsters appeared so fast, but it means rewriting the very first chapter of our universe's story. Think about it. Galaxies were forming faster than time itself should have allowed. It's like building a skyscraper overnight, during a blackout. And here's the kicker. The edge of the universe isn't empty at all. Webb's latest mapping shows something far more disturbing: density imbalances at huge redshift scales. Translation? The universe isn't just crowded, it's lopsided in a way that shatters our most basic assumptions. When this data is stacked with the infamous dark flow results, a chilling pattern pops up. Galaxy clusters seem to be streaming in one direction, as if something massive beyond our view is tugging at the entire fabric of space-time. NASA tracked this strange motion for at least 2.5 billion light-years. And it doesn't fade. If matter were truly spread evenly, this should be impossible. So what's out there? A hidden megastructure or something way stranger? And we're not done, because Webb's readings from the cosmic microwave background are hinting at something that sounds straight out of science fiction: another universe. Even before Webb, the Planck satellite caught bizarre anomalies years ago: a chilling cold spot and the so-called axis of evil, temperature patterns that shouldn't even exist in a perfectly uniform cosmos. Now comes the twist that's making cosmologists stare at their screens in disbelief. Some of Webb's massive galaxy clustering patterns line up perfectly with those same strange anomalies spotted in the cosmic microwave background. Different tools, different data, same bizarre result. That means this isn't just random cosmic static. The universe itself might actually be lopsided. And then there's the monster. The Hercules Corona Borealis Great Wall. This isn't just big. It's a structure so colossal it shatters everything we thought we knew. We're talking about something stretching over 10 billion light-years across. That's roughly 10% of the entire observable universe in one single piece. To picture it, imagine blowing up a balloon, but one side stretches way more than the other. Some scientists now think that's what happened during cosmic inflation right after the Big Bang. If that's true, the shape of the universe might be far stranger than we ever imagined. Here's the problem. Standard cosmology says this cannot exist. Gravity simply hasn't had enough time since the Big Bang to pull together something this massive. Our models predict a maximum structure size of around 1.2 billion light-years. Yet this thing is 8 times larger. And the worst part? As researcher John Halla admitted, we don't even know how big this cosmic monster truly is. Some scientists think it means inflation allowed far bigger patterns than we ever predicted, rewriting the rules of how the universe's first fluctuations formed. Others say maybe it's just a rare, lucky alignment, a once-in-a-lifetime statistical fluke. But a bold few are whispering something even wilder. What if it's a leftover scar from a previous version of the universe? One upcoming telescope mission could flip everything we know, because it might finally reveal the universe's true shape. And here's the mind-bender. Time itself may not be constant. When astronomers study light from the most distant objects, they're literally peering back in time. But the story that light is telling us is disturbing. Time dilation in some faraway supernovae isn't matching predictions. Using light curves from deep-field objects, scientists are seeing small but stubborn deviations from what Einstein's relativity says should happen. Out at the cosmic edge, events aren't unfolding at the speed our models expect. That sparked a wild question. Did time itself flow differently in the early universe? If so, it means cosmic expansion might twist time in ways no current model fully explains. If proven, it wouldn't just rewrite our map of space. It would force us to rethink the nature of time. This might even connect to the infamous Hubble tension, the mismatch between early and late universe expansion rates. Planck's data says it's about 67.4 kilometers per second per megaparsec, but direct measurements show closer to 73. That's a 9% gap, and it might be the universe telling us something deep. In other words, the clocks at the universe's edge might not tick like ours, and the further we look, the stranger time becomes. To explain this, some researchers are pointing to strange fractal-like patterns in the cosmic microwave background. Possible cosmic strings, scars from when the universe itself was born in a violent shattering. These would be the cracks in space-time, like fractures in cooling glass. And that infamous cold spot in the CMB. While some say it's just a giant supervoid, others believe it could be a bubble scar, left behind by a colliding universe. There's a chilling possibility scientists can't ignore. Our universe might have brushed against another, inside a much larger multiverse. And the clues may still be out there, hidden in the faintest signals from the dawn of time. Ancient gravitational waves, born in the first fraction of a second after the Big Bang, could still be echoing through space, and we just haven't caught them yet. Future missions like LISA could change that, scanning for these primordial ripples and giving us a peek beyond even the cosmic microwave background itself. If we find them, it wouldn't just tweak our models, it would rewrite what we believe we are inside. We once thought the universe was mostly empty. Now it's starting to look overbuilt, overcrowded, and maybe just one of many. The early cosmos wasn't some slow, graceful awakening. It was a full-on fireworks show that exploded into action the moment the lights came on. For decades, we pictured our universe as average, unremarkable. But every new deep space map screams the opposite. We're living inside something strange, something alive, and maybe without a true edge at all. To put it in perspective, scientists have long said the observable universe is roughly 94 billion light-years across, not because it's 13.8 billion years old in each direction, but because space itself has been stretching this whole time. The faint afterglow we call the cosmic microwave background formed about 380,000 years after the Big Bang, when the universe cooled enough for atoms to take shape and light to travel freely. And then there's the infamous Hubble tension. Early universe measurements say the expansion rate is 67.4 kilometers per second per megaparsec. Nearby galaxies say 73. That gap could be telling us something far more profound than we've dared to admit. But now, some scientists are whispering about something even stranger. What if that expansion rate mismatch isn't just a calculation error, but a sign we're looking at two different realities at once? Imagine layers of space-time, overlapping but not perfectly aligned, each with its own clock, its own rules. If that's true, we might be seeing gravitational leaks from another universe bleeding into ours. Evidence? Some galaxy clusters appear heavier than they should be, as if extra mass is being pulled in from somewhere we can't see. Others seem to vanish faster than physics allows, like they're slipping across a border we didn't know existed. And remember those density asymmetries Webb mapped? They could be the fingerprints of this cosmic overlap, scars left where two realities once touched. If upcoming telescopes confirm even one of these patterns, it won't just rewrite astronomy. It'll force us to admit we've never been in a single, isolated universe to begin with. And here's where it gets wilder. Some theorists now think our Big Bang wasn't the first. It might not even be the biggest. In one radical model, our universe is just one bubble in an endless cosmic foam, and every so often, bubbles collide. When they do, they leave behind massive cold spots, warped gravity zones, and, possibly, colossal structures like the Hercules Corona Borealis Great Wall itself. If that's real, then the birth of our universe wasn't a one-time miracle. It was just one spark in an infinite chain of cosmic ignitions. And here's the kicker. Future gravitational wave detectors could, in theory, record the sound of those collisions from billions of years ago. Not just images, actual echoes of universes smashing together. What we've called cosmic noise for decades might turn out to be the hum of the multiverse itself. So maybe the truth is this. We're living in a universe that's faster, denser, and far stranger than any textbook dared to imagine. A place that might have neighbors just beyond the veil, brushing against us in ways we're only starting to detect. Every new Webb image, every gravitational map, every unexplained anomaly is pointing toward one chilling idea. We may already be feeling the pull of another universe. The real question now isn't, are we alone? It's, how many are there? And when the next mission launches, the answer might change everything we know about existence itself. But here's the plot twist almost no one's talking about. If another universe is already influencing ours, it might explain every mystery we've been wrestling with. The Hubble tension, the cold spot, the strange galaxy flows, even the impossible size of the Hercules Corona Borealis Great Wall. All of it could be the shadow of something bigger, bleeding through the cosmic boundary. Some physicists are even daring to suggest this boundary isn't a wall at all. It's a moving, shifting frontier. A place where the laws of physics warp, where constants we think are fixed might start to drift, and where time could run at speeds we can barely imagine. If that's the case, the edge of the observable universe isn't just a limit to our vision. It's a warning that something beyond is already reaching in. And when the next generation of space telescopes light up, we might not just see it, we might feel it. Per megaparsec, the standard model says our universe is about 5% ordinary matter, everything we can actually see, 27% dark matter, the invisible mass shaping gravity, and 68% dark energy, the mysterious force that's speeding up cosmic expansion. If you've followed space science, you've heard this before, but even this foundation is now being shaken. And here's the cosmic cliffhanger. The James Webb Space Telescope is only the opening act. The upcoming Nancy Grace Roman Space Telescope will map billions of galaxies across thousands of square degrees, building full 3D maps with both imaging and spectroscopy. What could that reveal? Maybe the faint whispers of ancient gravitational waves, ripples in spacetime from the universe's first moments. Maybe the quantum limits of spacetime itself, the point where the universe's information capacity hits a hard ceiling set by quantum mechanics. And maybe, just maybe, the biggest twist of all, signs that our universe is just one bubble in an endless cosmic foam, or a single branch in a vast quantum multiverse. Every time we push our view deeper, The universe proves it's more unpredictable and more alive than our models ever dared to imagine. And the further we look, the stranger the truth becomes. So if you want to keep up with the next wave of discoveries, hit like, subscribe, share this video, and drop your thoughts in the comments, because the real story of the universe might be bigger than all of us.